Today. Hope you guys are doing well. So today we would be trying to continue um our journey in learning Swift concurrency. Like we did learn a little bit about how concurrency works. We'll try to understand more about it, and then we'll see how async can await, and then we'll see um, other models um, that are used, and then just let me check if the just let me check if the stream is up and running, because sometimes the stream does not work on. Okay, let's go to Twitch, because at times it does give us some issues. So yeah, let's see. Let's go to okay. Let's add this thing here. Let's minimize this. Let's maximize. Okay, so before diving into deep, or before going with the Swift concurrency, let's see a little bit about iOS architecture. So basically, this is iOS. This is iOS 13. So this is how the iOS architecture was made after like after the iOS version 13. This is how the architecture this is how the architecture was made after iOS 13. So now let's see something about the let's revise a little bit about. So this is basically, so in general, iOS is basically an operating system, right? So this is basically the OS basically represents that this is an operating system. Now every operating system performs different distinct features, right, or distinct functions. Now the I is basically for how the Apple ecosystem is, and so iOS is for basically for phones, and Apple phones have iOS. So this is mainly for an iPhone device. The iOS used in an iPhone is called as an iOS, and then we'll see. So Mac OS will be a little bit different as compared to how Apple iOS is, as compared to iOS for iPhones. There won't be much changes, but it will be like little bit. So let's see. Now so you see, so operating systems, basically we had two modes, right? So we defined two modes in operating system. One is something called as kernel mode, and then another is basically called as an application or user mode, right? So this is how we had defined our code, right? We said the OS is generally has two modes. Now the kernel mode is also called as this is something called as privileged mode. So this is a privileged mode, and the kernel can directly access the hardware, right, using system calls. So we'll be making use of system calls here to access the hardware. Now the application mode, what it will do is, so it will we need to contact the kernel. So internally there will be something to have the call to make a call. So if you want to access the hardware here, we would be making a call to the kernel, and the kernel will then uh, link our OS, or call the make the system call and call the necessary hardware, right? Let's see a little bit about how iOS is, or Apple operating systems is. Now, so basically we have two mode, there will be major mode, right? So this is my application mode. So I will have to color it something. Yeah, this is basically my application mode. So the Cocoa Touch layer is, so it is called as Cocoa Touch because in an iPhone you will be um, accessing all the applications using touch, right? The Mac did have the touch feature, but then now it is being removed. So the touch screen is what is referred to as Cocoa touch layer. This is nothing but where we are in the, where we can access the hardware, the application. So by launch the applications, we'll be using this touch feature, right? So this is basically we are at the application layer here. Now if you see, then we have, so basically in this touch layer itself, oh no, what happened, I have to, you have different kinds of features available, right? So first you have UI kit. So UI kit is basically for our user interface, right? Our user interface is going to be developed in UI kit. Then you have map kit, then event kit UI. So nowadays with this UI kit you have Swift UI also being integrated. Now then you have message UI, the message application. Then you have game kit, then you have push kit. So these are all basically at the application layer. This is where we are going to work with the application itself. Now this is my, so the core OS is, or this layer is basically my kernel. This is where we have the GAN central dispatch or the kernel present, and then we will be accessing the hardware using system calls. So the two layers are basically defined, right? So as per our knowledge previously, the OS should have two layers, right? So basically this is the application layer. So basically at the Cocoa Touch we are here, and then when we go to core features, this is basically core features. So when we are in the core feature sections, basically we are at the what you say, the kernel layer or the bottommost layer present. Now there are a number of API, there are a number of layers present in between, right? So you have, for example, media layer, one of them being media layer, then you have core service layer. Now why do we have these layers, right? So like, what's the advantage of having layers? Now, and what is this? So what are these? These are, so in these layers basically we'll be having APIs to access very different, the to access different hardware, right? For example, so core media layer will basically deal with media. So media can be of two types, right? It can be either audio or video, right? It can be so media is broadly so media, when we say, it can be of two types, right? So we can have an audio media player, and then we can have video, right? So both combined together will be my media, right? So then when we come to video, we'll need some sort of animations. So we need some libraries for animation to handle graphics, to do 3D generations. So then this is where now this is where our what do you say, media layer comes. So we have the core animation API, then we have core media, then we have AV. So AV is basically for AR, right? So it's basically like for so nowadays we have that feature of where we have, so recently Apple launched that AR kit, right? So AR basically stands for So AR in is basically referring to the what do you say, augmented reality, right? So the basically for the so now we have the now with Facebook having this augmented reality thing. So augmented is basically fake, right? So you can like for example when you nowadays on when you go on Instagram marketplace and you're buying suppose a bed, right? So what you can do is you can create suppose I'm buying a bed, right? This is my bed. So what I can do is so I can go to Amazon, and then when you search for this bed, what you can do is so using AR you can see how this bed will fit in your you can do a map out of your room, and then you can just see how is this how it's been placed inside your how does it look inside your room. And this is my yeah, this is my bed frame, right? So that is nothing but all part of augmented reality, right? So nowadays you have those Ray-Ban glasses as well, which are all having the augmented reality feature. So then yeah, that is for that itself we have an API here. Now the now since why it is called as an API, or why we are referring to it an API. So remember at the end of the day, even when you're going to do augmented reality, right? So what you need is so this is your mobile phone, right? So this is our mobile phone. So basically this is our mobile phone and this is our application that is running. Now this application needs to internally to access the camera we need to go to the kernel, right? Then we need to process the image as well, right? The kernel is what is going to call the actual camera hardware. So this is the where my camera is basically light sensors, right? This is what is going to capture that light. But then by having those APIs, what are we doing is so now whenever you capture the image, first what you need to do is you need to process the image, right? So we need to process the image, process it, process the image. Then we can change the magnification, or you can crop the image. So this is all software features, right? That so before the before the kernel senses the image, we need to perform all of them, right? Now, if hence we make use of APIs, right? So this API have additional features, for example, processing the image, generating the vector, the 2D vector space. Then, so when nowadays when you capture it shows like faces, right? So that all is being taken care of by the API. So why we need these APIs is basically they will have additional functionality already built in. Now, if we don't have this API, then if or if I directly access, we're directly trying to access the kernel, right? Now the kernel will be able to access the kernel and then it will get the camera. But the thing that is going to back, it will need a lot of processing, right? We will only so the camera will send basically this error, this matrix, right? This matrix to image generation is what we need on our screen, right? So that needs to be performed by something. So this API is going to take care of all that feature, and it's basically these are called as application level API, right? Now, why do we have these APIs integrated in the OS itself? The reason is because like the iOS team soon realized like the capability of iPhone, right? You use an iPhone basically to get a better image. You need to capture better images. Then you need like audio. It has ability audio output. So basically, the iOS developers realized the common case used of uh, iPhone, right? Like common usage of how iOS will be. But then, so what they did is now instead of using any third party library, so using a third party library, what they did is they kind of in made this inbuilt inside the iOS architecture itself. So inside the iOS architecture itself, they have made this thing inbuilt so that there is no need for us to access any third party libraries, right? Because the moment you give access to third party libraries, you will have to the trade-off here will be you will have to give up some of your security features, right? So Apple does not want to trade security features, right? It was the first one to introduce like the feature when someone you can now turn off unknown calls, right? So you can turn unknown numbers off. They won't be able to see your profile, and then anytime an application is trying to access any core feature, for example, it will give you a notification, right, saying we are trying to access some core feature. And then even if uh, even if that core feature will be updated, but then what we would be doing this we would be even if we have that even if we have that core feature here, then what we would be doing is we would be trying to uh, we would be basically trading off our features, right? I mean, we don't want to what do you say, trade in on our security, right? Because security is very important, right? So then instead of using a third party library for performing the segmentation in itself, so the developers soon realized the common cases of how iPhone would be used, and instead of having a third party library being used, they itself integrated in the iOS architecture, and then it is present as the APIs, right? So these are basically all so this is basically an API, right? So for example, OpenGLS, this is again for all my 3D animations, right? This is for 3D. Then we another had something called as core location API, core found. These are all APIs that have been integrated as and when things involved, right? So now we Apple has a support for neural engine. So now if you see it like from a developer's point of view, neural engine is directly being present, right, in Apple ecosystem. By doing this, what Apple has integrated is Apple has directly integrated the neural engine in the iOS architecture itself. So basically, it's present in the OS itself. So what they have done is, so now they have added something called as new features, right? So then they added something called as core. So if you go over here, so in this core services layer, they have added additional feature. For example, that is nothing but called as core ML. Okay, let's see iOS 18 architecture that does have this core. So in the iOS 18, okay, this is nothing but what they mean by software purchase, right? Do we have that iOS? No, do we have the iOS? Mm, okay, so now this is the old, I guess. This is not the so in iOS okay, iOS 18. Uh, so what they have done is they have directly integrated the neural engine thing in the iOS architecture. I'm trying to understand the so what they have. So it is of still a four layer architecture, but in this core services layer, they have added an additional feature called as what do you say uh, core ML. So this is basically which is going to take care of all ML features. For example, yeah, face recognition, transformers, and other. So these are all modeled and developed by iOS developers, right? So they have a so it's now basically integrated in the OS itself instead of you using a third party library, because the usage of ML has become so increased. They what they did is they kind of in my core services layer. Now remember this is also an API, right? Now, for example, you have your network calls, right? So for example, your system configuration. This is my network thing. Previously, it was called as Next. So initially, it was managed by a company called as Next, right? Then later on, they converted to this. To like it was when Steve Jobs came back, he brought in Next as well, right? So this is what is so this is what happens when you run a network layer. I mean, when you make a fetch call, and then in this network layer itself, you have all the TCP/IP stack being TCP is a software program, right? So all of them have been present over here. Now it's called a core service layer because it is the reason because it provides essential system functions, right? For an API that support higher level functionalities, for example, data management. So for any application, in if you are developing an application, so the core feature would be like accessing the data, how are you storing the data, file management, and so on, right? So in any app, if you are developing, there are certain something called as core features, right? uh, Core features, uh, core features in an app are basically for example main functionalities, right? For example, whether I'm making so whether so like for example, where is my data, like which type, what type of database am I using. This is one of the major features. Then how am I making my network calls. Then so instead of then they have um uh then how am I managing uh core data feature. For example, am I so this is this day then whether I'm storing it inside the phone itself, phone memory itself. So phone also has a RAM, sorry, not a RAM, it has an external SSD as well, right? So nowadays you have no, inside the chip itself you have external storages present, and those are not on the CPU, but you have something called as ROM memory present here. uh, Random, you know, no, it's not ROM, I guess. uh, it's RAM is on the CPU, right? So you have ROM memories, for example EEROM or EEPROM. So whether I'm storing my data in the database or whether I'm having my external, so by external, okay, there's a difference between external and portable, right? So external means it is not on the same chip as my, so I have a CPU and a random access memory, right? So it's not a, if it's not on the same chip, then we say that it's an external memory. Then we have okay, then making the TCP IP stack being present here, that is going to interface. So the this needs to interface to my network interface chip, right? NIC. So this linking has to happen. So these are basically considered as the core features. And then so lately what they have added is, so instead of having an instead of us relying on third party, since because AI is evolving so fast, Apple has taken the first step and then they have added core ML as well. So all the these are all softwares. For example, all the ML features. For example, transformers, your face recognition, Then you have other features, for example, text transformation, text to speech, and then lately they were doing that emoji thing, right? So where you could get generate your own avatar or something. So even that has been added on by, even that is done by this core ML thing, right? Then you have the transformer has been present for um, so neural engine basically is the hardware, right? So you need to write a, this is the hardware. The engine is nothing but the hardware. Now these have to refer to the hardware, right? So then these are all added in the core layer. The reason because all of these features will be need to be present more closely to the OS, right? So the way if you think it that way logically is all of these core features will be accessing hardware a lot. So it has to be a layer which is much closer to the hardware as compared to the core service layer or the core other layers, because these are basically going to be accessing the hardware a lot. So then, oh no, yeah, as compared to the media layer, this is going to access the hardware a lot, right? So hence we have placed this more closer to the kernel so that the interaction can happen easily. Now concurrency is basically, now remember Swift is a single threaded program, right? It's a synchronous program. Now what do we mean by a synchronous program is it runs from top to bottom, right? And it does not wait for anything. So if you start running it, it will run from top and it will only stop until you have either completed the execution or there is no line for us to read over. So this is basically what we say by synchronous, right? Now if you have any asynchronous operation, what is going to happen here is basically, suppose I have an async operation here and I'm waiting for data to fetch. So if I write it in a synchronous way, this part will be blocked, right? So at any point we don't want our application to be, or the main thread of the application to be blocked. So that is why we make use of something called as concurrency. Now there is a very subtle difference between concurrency and parallelism, right? Now we always say that there is something parallelism. So parallelism is basically, it's like parallel processing, right? So you have parallelism is parallel processing. For example, you have two parallel lines, right? This is parallel processing. Now concurrency is not exactly that. Concurrency is basically we are doing some sort of async operation on the back end so that the main thread does not stop. So concurrency is concurrent, right? So concurrency is related to concurrent things, right? That means they are going to happen multiple things at the same time. There is nothing about processing that is going to happen. Now there are multiple ways in which you can achieve. So concurrency is basically multiple tasks in process. Now we are not dealing with whether you have multiple processor or a single processor. It's basically we are going to make a switch, and then yeah, for we are going to make a switch, but then parallelism is basically having multiple tasks running at the same time. So this is multiple tasks in progress, they are not running currently, they might be in a queue waiting. There might be some waiting time, right? So they might be present here in the queue. The moment the OS like they get their chance, the OS thinks that it's time to schedule them, they will be scheduled onto the processor. So parallelism is more related to having multi cores. So when you have a multiple core system, oh, so now yeah, parallel or multiple. Now there is subtle difference between multiple processes and multi-core as well. Now multiple processes, what we do is we have a, okay, so multiple processes is something else. Now parallelism can also be classified as multi-processor. So a multi-processor environment will have more than one processor. Like processors will be more. But if you see parallelism, what is going to happen is you're going to have a single chip, but then you're going to have different cores on that chip. So each core is basically what do you say, a CPU plus CPU plus ALU, the CPU plus ALU kind of structure. So what you can do is, since this will be on the same chip, and when you say about multi-processing, you will be on different chips. You are trying to do different chips processing. Now, same chip will be much faster because buses are internally linked, right? So data can be transferred easily. Multiple processing, the data bus will be external, right? So we'll have to move from one chip to near the another. So it might take some time. So that is what concurrency is. Now you can achieve concurrency in multiple. Okay, there are multiple ways in which concurrency can be achieved. Okay, so let's see. Now, there are multiple ways to achieve concurrency, right? So concurrency can be achieved using multiple ways. Either, for example, in JavaScript, we have something called as the either you use async programming, or you make use of multi-threads, right? So you have multi-threads. These are both going to contribute towards your concurrency. Now each has the advantage and disadvantage of the over one another. Now whenever we talk of web, right? So if you see a web OS architecture, I mean, for example, if you see a Node.js or a if you see a Node.js engine, it won't have any different layers. The reason is, you on web, we are the way people use web is just for browsing and uploading images. Like the job of the segmentation and all, that is not the job of the web, right? Or to generate a good image, that is all taken care where the image is being clicked, right? So in on web, you will be only uploading the image, and then you won't be performing any serious image processing happening over there. So hence in the OS architect, so there is no specific web OS kind of thing. Or and even if you see like the OS on which node will be installed, it is that OS's job to take care of everything, and Node.js does not have a specific API for doing this thing, because we won't be using the web applications for that, right? I mean, it's understood that we mostly web will be used either for logging into a server, or the other way would be to browse the server, browse the web. So that is why we say that is why we don't have a specific OS in web, right? So like, for example, like it's the web, the OS built on top, right? um because that is how web apps are made. Like you won't be able to, you don't need that much level of concurrency there. But however, it's inherently built inside Node.js, right? So Node.js is inherently concurrent, so you don't need a OS kind of thing to have that specific feature, right? Yeah, so Node.js and everything, they will have dedicated thing, right? So we don't need a dedicated operating system just for the web. However, in iOS or any mobile application, we will need to manage the hardware life cycle. So it's not logical to have a traditional WebOS kind of thing, but then in mobile you would need, because you need to manage the underlying hardware as well, right? So hence we have this iOS architecture kind of, hence you have mobile OS thing. Whereas if you see, it's just in web it will be like mostly HTML, CSS or JS kind of thing, right? So that is a very distinguishing feature why we don't have like specific WebOS or as compared to, like, we have iOS for iPhone, right? You have Mac OS. So why, like, I mean, it's the basically the use case for which we build mobile applications, right? So because Node.js already has concurrency, right? It manages concurrency on itself. Yeah, so I guess that's all for this lecture. If you guys like this video, please subscribe to my channel, and please select the like button, and then that keeps me motivated, right? Like, I don't say this thing much, but yeah. So that's all for this lecture. I'll see you guys. So in iOS, we will be using the grand control dispatch. Now that is, so now what iOS has upgraded. So what it did previously, we only had GCD that is to care of that used to take care of async or async operations. And now what we have done is, we have inherently, there is a layer over this, so we have added Swift async plus the grand control dispatch that is going to take care of our all async operations. So we need not to be like, we need not worry about because this is this came in. So Swift async was introduced because in web applications you have an easy sync await kind of feature, right? So if you are across platform, or if you are developing across for example, if you are making a web app and then you need a phone app as well, then it kind of becomes very easy for us to understand the code, right? Because in that as well you have a single await. So then this was added later on when this came on later on. Previously we only had this grand control dispatch. So this is basically a layer on top of GCD. We have added something called as Swift async await. So using which itself we'll be able to have our concurrency being achieved. So I guess that's all for this lecture. I'll see you guys in the next one. Till that time, take care, and please like and subscribe to the channel. Thank you. Yeah, that's all for this. I'll see you guys in the next one. Till that time, take care. Bye bye.